if we're thinking slope, and I'm looking at A to B, how many do you have to go up in order for you to go over to B? We're going up. Looks like we're going up 5, right? And then counting over how many? Looks like 11. And do you notice how I connected already? I connected A to B and then I went A to D. Where does C have to be, or why am I saying C has to be in this area? Because that is kind of true, yeah. Remember when you label your quadrilaterals, we always said you're going in order in a circle? So if I'm starting here at A and I'm going around to B, that kind of forces C to have to be in that area to get up to D. So that's something else you want to keep in mind. The order of the letters is going to kind of tell you where C has to be, which is somewhere over here. Okay, so knowing I started up 5 over 11, how is that going to help us to find C? What could I do? Down 5 from... Up 5 from D. Okay, let's try that. So go up 5. 1, 2, 3, 4, 5. So here's my up 5. And then go over 11. So here's 3, 4, 5, 6, 7, 8, 9, 10, 11. So if that's the case, let's connect them and let's see what's going on. Kind of looks like a square, number 1. You always want to make sure it looks like it. Okay. So it would definitely tell you that this side has a positive 5 over 11 slope, and this has a positive 5 over 11 slope. What should be true about these two if it's a square? They should be parallel to each other, number 1. And what should they be to like the adjacent sides? Perpendicular. So if I have one slope that is 5 over 11, what's the perpendicular slope? Negative 11 over 5. So what I would do is, okay, let's count it out. So if I know this point here, I should be able to count down 11. So we're going to try this. I'm going to count down 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's my down 11. And then over 5. So I got 1, 2, 3, 4, 5. So what do we think? Looks good. We got perpendicular lines. It's in order. I have A, B, C, D. So then the only other thing I need to do is tell you where is C located. What's the coordinate? Positive 8, it looks like. And then we're going to go down 5. Looks like positive 8, negative 5. That would be our location for C. Do we see how that works? Slope, we can definitely do distance. Slope is going to be faster because you can always count rise over run. So things you want to think about are they should be parallel, opposite sides should be parallel. More importantly, because it's a square, adjacent sides should be perpendicular. Yeah?
Can we do it like the work that we did like that, or do we have to do it all like that?
No, you can do the work like this. Notice how I've labeled things. That's fine. Okay, what I would say then is maybe at the end, because it's saying like support with calculations and explanations. So you did this kind of thing, we did that kind of thing. Maybe show me, maybe give me a little explanation that says that these are perpendicular because they're negative reciprocal slopes. Something like that. Give me a little bit of an explanation to go with that, if that's how you're doing it, if you're not going to do the calculations. Does that sound good? Okay. We're going to, because we did a bunch of proof stuff, I want to jump over and go to question number 5. We will get to proofs, don't worry. I just want to make sure that we have some algebra today. Okay. So number 5, it's saying we have the perimeter of a square. Perimeter is meaning what? All the sides. Added up all the sides. So the perimeter of a square is 24. So how do I know what the value is of one side? Divided by 4, right? Okay, so 24 divided by 4, that's going to give us 6. So I have 6 going all the way around, and it's a square. So I know they're all equal, and I know I have right angles. And it's saying in simplest radical form, so this simplest radical form, that's like what we did on the warm-up. It says find the length of the diagonal of the square. Okay, so what are we going to do to first off at least find it, even if it's not simplest form? How am I going to solve for x? A squared, the a squared plus b squared equals c squared. Okay. And again, I just need to know which one's your c squared. The x, okay, so we have 6 squared plus 6 squared equals x squared. And 6 squared is 36. What do we notice about 36? What type of number is 36? Perfect square. Remember what we said. When we simplify this, we want to find perfect squares. If we add, you get 72. But now because it's saying simplest radical form, I want to find two numbers that multiply to be 72 where one's a perfect square, and there we go. So use that to help you. Okay? And so we're saying the square root of 36 times the square root of 2 should equal x, since I had a square root back here. And we know 36 is your perfect square. What's the square root of 36? So I can say 6 square root of 2 is equal to your diagonal length. So this is your simplest radical form. When it's saying find simplest radical form, that's what it is. Okay, that was fun. Okay. Let's go to number 6. We got a couple of word problems to throw in here. Kimmy is designing a square garden whose diagonal is exactly 16 feet long. Okay, draw yourself a picture. So here's her square garden. Diagonal is 16 feet long because I know it's a square. We know all sides are equal. We know we have right angles. And it said she would like to place fencing around the perimeter of the garden so that it is completely surrounded. If the fencing she likes comes in 12-foot long rolls, how many rolls is she going to need and how much fencing will be left over when she's done? Okay, well, the first thing we probably have to figure out is what's the length of one of the sides. What do I know about the lengths of the sides? They're equal, and I have no idea what they are. So if I were to call one x, they're all x. Okay, I got to figure out what that x is. So I'm back at a right triangle, and I am back with, I'm missing sides, but I want to solve. So what have we done when I have a right triangle and I'm trying to find the length of a side? A squared plus b squared equals c squared. So it doesn't change. Again, which one's your c squared? 16 this time. So notice what we have. I have 16 squared. The a and the b are both x squared. Don't panic. Okay. Breathe through this. I have 1x squared plus 1x squared for a total of how many x squareds? 2x squareds. And if I did 16 squared, that's going to get us 256. Okay, I want to solve for x. Divide by 2. So now I have x squared is equal to 128. Now here's a place where I would tell you decimals are going to be a little bit more helpful because we're trying to find total feet, total fencing. They don't sell fence in square roots. Okay, they sell it in decimals. So I would say if we were to square root this, what are we going to get? About 11.3, 11.31, somewhere around there, right? So what that's telling us is each of these sides is about 11.31-ish feet. So if I wanted to find the perimeter, how would you find the perimeter? Add them all together. So I could say the perimeter is either 11.31 plus 11, or I could say 4 times that, right? Okay. So how much is your perimeter in this case?
45.
All right, so we got 45.24 feet. each roll is 12 feet long. How many rolls are we gonna need? How do you figure it out? Sure. So 12 times 4, we get 48. What if I just did like 11 times 4? So that's going to get me 44. Is that enough? No. So I'm going to have to do that 12 times 4. I'm going to need to have then 4 rolls in order to get enough. So that's one way to process through it. Another way to process through it. You got a length of about 11.31. About how many rolls is it going to take per side? 1. So I know I'm going to need 4 rolls. Another way I could process through it is if I could take this and divide this by 12, and that's going to get me somewhere around 3.77. What's that telling me? I need 3 and a little bit more rolls, but can I buy 0.77 of a roll? No. So again, I'm going to need 4 total rolls. It's a little bit different, still taking that square concept, but trying to get you maybe a real life application here. Good? Oh, I didn't finish it. What does it say? How much would be left over when she's done? What is it? 3.24 feet would be left over? Yes. I will go with that. Thank you. Because we know if we have 4 rolls, I have 48 total feet. So I would have to subtract that out. And that would get me how much is left over. Okay. All right. Let's do number 7. And then we're going to try some triangle stuff. So it says, in the diagram at the right, we have a square ABCD. And it says it's drawn and the midpoints of its side have been marked. So what it's saying is E is the midpoint of AB. So I know this must equal this, right? And F is the midpoint of BC. So I know this has to equal this. But I'm going to stop and think, but if it's a square, I know AB and BC are equal to begin with, right? Okay, so now if I've taken 2 equal parts and I found midpoints of the 2 equal parts, what should I know about all 4 of these lines so far? They're all equal. Right? And if I do that process all the way around, I'm going to see that all of these little guys are equal. Okay, other things that we know, because ABCD is a square, I know that all of these are right angles. So notice what type of triangles we're getting. We're getting right triangles, and because I have 2 sides that are equal, what type of triangle is a triangle with 2 sides that are equal? Isosceles. So now these are right isosceles triangles. So let's keep going with it. If they're isosceles and I have 2 sides that are equal, what do I know about these guys? They're equal. Okay, so let's keep going with it. No, we haven't really read too much of the question. Do you notice that? Like, we've just used that idea that we have squares and midpoints, and we're starting to kind of put together a whole bunch of information. So in a triangle, I know there's how many degrees? 180. So if I know there's 180 and I already know one angle is 90, how much is left over? Okay, but now we just said because it's isosceles, it's right isosceles, these 2 angles are equal, and that means each of those have to be 45. So what I found is all of these triangles here, 45, 45, going all the way around. Do you see that? Okay, so now we're going to keep going. It says we have to give an explanation for why EFGH must also be a square. So they're saying I took a square, I connected all the midpoints, I got this new guy on the inside. Why does this inner 4-sided figure, why does this inner quadrilateral also have to be a square? Yeah.
All the things from 90 degrees because you look at like the mercury.
Yep. Exactly. So I know all 3 of those have to total 180 degrees because it's on a line. They're linear. I can't call them linear pairs. They're adjacent angles on a line, so they're supplementary. So if I know that 45 and 45 is a total of 90, and if I subtracted both of those out, oops, 45 and 45, we get a total of 90. So that forces this to be a 90-degree angle. And could we do that process all the way around? Right? So I could do that again over here because I know that that's also 45. So that also is 90. And it has to be square. Good? That was fun with squares. Questions I can answer as far as fun with squares. So if you look at this worksheet, you are going to see that most of these questions are the same kind of questions. Numbers 1, number 3, number 4, they're basically asking you the same thing. I think these all came from Regents exams, where they're saying to prove it's isosceles, prove it's not equilateral. Almost every single one of them says that. The only difference is number 2, where it says find the perimeter. So you have to know then the difference between isosceles and equilateral. What is an isosceles triangle? A triangle with 2 equal sides. What's an equilateral triangle? All 3 are equal. Equal meaning, what am I testing? Distance, midpoint, or slope? Distance, right? Because length. They want to know how long it is. I want to know how big they are. So what it's saying to me is test the 3 sides. If it's isosceles, when you're done doing the distance, how many should be the same? 2. If it's equilateral, when you're done with the distance, how many should be the same? 3. So not bad. So most of, not all, but I'm going to say most of these triangle questions are saying distance. So we're going to try this first one. And what I'm going to say is, why don't we split you guys up and we'll do, you guys are going to do the distance of WI. You guys are going to do the distance of IN. And you guys are going to do the distance of WN. So everybody has one distance to work on right now. Okay, WI, what do we get for a WI? Square root of 40. And what about IN? Square root of, what is it? I got something different. I got 32, square root of 32. Watch your negatives. Remember, when you square a negative, it will always turn out positive. Okay, so even in your calculator, you got to put that in parentheses. Be careful with that. How about WN? Square root of 40. Okay, so it wants us to show it's an isosceles triangle. Have we done that to show it's isosceles? Sure have, because if I'm looking at WI and I'm looking at WN, what do I notice about them? They're the same. So I can say same distance, so they are congruent. Okay, and just like any other coordinate proof, you need to end this with a statement. So we could say here, triangle WIN is isosceles because why? Sure, 2 sides are equal or are congruent. They're the same length. 2 sides have the same length. We've already done all the work in part A. All of your calculations are done to answer part B. And part B just says, okay, show it's not equilateral. So how could I conclude that it's not equilateral? Good. Okay, so triangle WIN is not equilateral. Because all 3 sides are not equal. And do you know that you can do not equal, not congruent by doing just a congruent sign with a slash through it? That's okay if you want to do that. That's saying not equal to not congruent. So nothing really changes when you get a triangle coordinate proof versus a 4-sided figure coordinate proof. Only thing that changes is you have one less side. That's it. Okay. A question that I have seen come up before that is not on this sheet, but let's talk about it. So if they said to you, prove the triangle is a right triangle, how would I prove a triangle is a right triangle? What does it need to have? In order to be a right triangle, it must have a right angle. How do you prove right angles? Perpendicular line, I'd have to test slope. So I would have to do the slopes of 3 sides, and 2 of the 3 should be flipped and negated. There's your right triangle. That's about as fancy as we can get with coordinate proofs and triangles. Okay. Only other thing I've seen them do is such as number 2 down here. So let's maybe talk about number 2 and let's see what we can do. So we have this triangle, and it says we have to find the perimeter of the triangle. Okay, so if I'm finding the perimeter, what are we finding? Distance, the length. So guess what you're doing again? You're doing the distance formula again. So I'm going to split you up, and everybody again, you're going to do one. So I'm going to do, you guys are going to do the distance of AB. Okay, you two are going to do the distance of BC. And my last 3, you guys are going to do the distance of AC. So let's do those distances. Okay, distance of AB, what do we get? 5. Okay, that one simplifies nicely. How about distance of BC, what did we get? 10. Distance of AC, you had a little bit more fun. What did you get if we kept it in square root form? Square root of what was it? 125. Ooh, I have a mistake on my paper. Can we reduce that? So let's think of that process. I want 2 numbers that multiply together to be 125, or one's a perfect square. I'm going to give you a hint. 25 and 5. What's the square root of 25? 5. So if we were to add up this perimeter, I have 5 plus 10 plus 5 radical 5. When you simplify this, the only numbers you can combine are the 5 and the 10. Your perimeter turns out to be 15 plus 5 radical 5. And our label here would be units. Okay. So, test on Thursday. Your review packet that I gave you, hear me now, believe me now, your review packet is homework. Your review packet, I'm asking you, assigning you to do odd problems only. Your answer key will be up on my website so that you can check your work. I will collect it on Thursday so I can get you a homework grade. Okay, make sure to study hard. This is a test grade that's a big part of your grade.